All right, so what's this lightning thing you guys work on? And you want to give a brief introduction of who you guys even are?
Yeah, I guess I could start. So hi, I'm Matt. I have worked on various things in Bitcoin over the years. I now work on the LDK project as a part of the Spiral team at Square. I guess we're Block now. So we have, I guess we're unique in the Lightning implementations here. We're not actually a Lightning node. We are a toolkit to build a custom Lightning node. So we support various people building different Lightning nodes using LDK to do a lot of the hard work.
Yeah, hi, I'm Chris. I've been in Bitcoin for 1/3 of my life, I just realized, since 2009. And I'm now working for a Blockstream on Core Lightning, and of course the specification, which is probably why we're all here.
Definitely. Hey, I'm Lalu, co-founder and CTO of Lightning Labs, working on Lightning for a while now too, kind of like involved in some of the early stuff on the spec side. I'm like the lead developer of LND, which is the implementation of Lightning. One cool thing about it, it kind of like runs everywhere. You can do it on mobile, iOS, Windows, FreeBSD, random other BSDs you never heard of, and obviously we participate in spec stuff as well.
Let's actually quickly get a round of applause for Lightning Labs for their recent huge round of capital that they just raised.
Thank you, thank you.
So what's exciting now, what comes to mind for me is Bolt 12, route blinding. What's new in Lightning? What do you guys care about these days?
Bolt 12, obviously. I mean, we all got hats.
Yeah.
So that's
Look at
what
mine.
makes
Cool.
decisions around here is we just go by the hat.
And it's just the hats.
Just the hat.
Right,
Just the hat.
Oh, yeah.
The
There's
technology.
no
we're not
no
gonna
tech
go about
behind it.
that.
No.
That's hard. No. Yeah. I mean, Bolt 12 is awesome. It has a few different parts. So like Onion messages by itself is cool. So the potential to be able to do. We have this great network. Obviously, it's not set up for high bandwidth messaging, but being able to use it to provide some privacy for senders doing stuff like requesting invoices, right? You have like LN URL is really great if you want to know the client's IP address, but sometimes you don't care and you don't want that information. So stuff like that, and then route blinding, so improving privacy across the board there, plus Taproot with PTLCs. Like we have a lot of these kind of small incremental privacy upgrades coming down the pipeline that are all going to be pretty great, and then hopefully a bunch of UX improvements on the side with that from new messages and other stuff that we can build using them. Absolutely,
and one of the more exciting things that I'm seeing in the near future is the update of the Gossip protocol too. So the Gossip protocol has been growing organically for the last couple of years. We've seen a couple of places where we could improve it and try to improve it, but now the protocol is pretty much a monstrosity and needs to be overhauled completely. And while we're at it, we can add a lot of new features. For example, we can decouple now or there's plans to decouple the on-chain footprint from the actual channel, which should help us make the entire network much more private. And in combination with some other things like route hints, we can actually make this network much more compact and much more usable for the end users as well.
Definitely. Yeah, I say things I'm excited about are kind of like generally just Taproot related stuff. As far as like being able to use Music 2 and also kind of like actually make certain components a lot more compact basically, and certain things around kind of like making HLC a little bit easier to handle as far as like not even payment hash. I think one other interesting thing would be kind of like the actual transition to Taproot, because like today we have like 80,000 channels, 3,000, 4,000 BTC or something like that. So obviously everyone close channels all at once. That would be kind of like so many on-chain transactions as well too. So I'm working on some ways to basically allow people to like do that on the fly basically. So rather than kind of like everyone like open and close a channel at once, it's kind of okay. Well, we'll kind of like have another spend off chain and defer that. So we still need two transactions eventually. We can at least kind of like defer that a little bit further out, right? That'd be really cool because then people can just update and all of a sudden they're able to use Taproot stuff. Then the bigger thing obviously is like the PTLCs, which actually fix a bunch of issues as far as like privacy in the network. Because today you actually have like the same identifier in the entire route. So therefore I'm in two different places within the route. I basically know what it is, but now it's actually going to be randomized. And PTLCs compose of things like DLCs as well too. So I think this year is going to be a lot of stuff, working on the spec side. And I think that's one of the things. There's just like so much stuff at the end of the day too, and everything is almost almost immediately implementable as well too. So you kind of like have to say, okay, maybe some restraints, see what we're going to do, whatever else, how we're going to like allocate our resources as well too. Because at the end of the day, like even though there's things a lot bigger, there's still a few people that really know this stuff very intimately. But obviously, we're trying to make that a lot more widespread. I worked with Andreas and Renee on the Mastering Light Network book as well too. Definitely get that. If you haven't got it already, it has a bunch of really good information about as far as the bolts as well. Because the bolts are kind of like written for people like us basically. And you need kind of like a little bit more accessible thing. Okay, like how do the feature bits actually work? How do like routing work? Things like that as well too. So education is getting a lot better, and just generally a lot of the developer education is getting really good these days as well. So.
Yeah, and how could I forget, of course, splicing,
Yep.
which we've now built the groundwork using with the dual funding proposal, which basically allows us to collaboratively create a transaction among a number of peers. And looking a bit further on, I think we are all waiting on L2 being a possibility. Of course, had to be me mentioning L2 here, because I'm known as the L2 shill.
Yeah, you gotta get it in.
And any prev out is required as like a soft fork for that, correct?
So any prev out is soft fork that we need for Bitcoin on chain. Though there are other mechanisms that we could use, opctv in combination with checksig from stack, or tx hash and checksig from stack. Both achieve the same goals. So we were pretty much just sitting and waiting for either of these to happen, and to give us that capability of doing some really interesting channel stuff. Like, for example, multi-party channels, where any number of participants can basically share ownership of a single UTXO, giving us a couple of more orders of magnitude on top of Lightning.
Definitely.
TLDR, we all have about 5 years worth of engineering roadmap planned out, and we'll start delivering this stuff, I don't know when we get to it.
Soon, basically.
Yeah, sort of the head of what we're planning to do is getting further and further away
Right.
from us. And
Yeah, the to-do list keeps growing. Like, that's the thing.
Right.
And I think one cool thing about Lightning is like, there's certain things that can improve the protocol that aren't necessarily like kind of like protocol level changes. For example, like in the past year, we've seen a lot of people actually working on things like pathfinding, which is a big thing for improving UX as well too. It's one of the things where like the spec says, get from A to B, doesn't really tell you how to do so, right? So we've all been kind of like filling in the gaps. Then some people do like, some newer kind of like probabilistic approaches as well too. And I think that's gonna be really cool because like, once we can move larger amounts of payments, and also like payments reliability gets a lot better. Because like the worst thing is like someone tries and obviously it fails, right? But I think we're getting a lot better now. People are also getting like really widespread deployments with like Cash App as we're getting a lot more data. Now it's like, okay, like people can actually use Lightning now, which is also really great for like developers and companies, because now it's okay, well, I actually have distribution, I actually launch my application versus, picking from like 5 different wallets that, all are a little bit different. So I think that's a really good thing as far as maturing user experience, with kind of like things at the edges, like people can just update protocol-wise, algorithm-wise versus protocol-wise as well.
And then more research across different types of routing, because there's different things you want to optimize for, whether it's like speed of the payment, or maybe you want to optimize for lower fees because you're like rebalancing or doing something in the background. Maybe you want to optimize for privacy, which is somewhere that like how to do good private routing is not something that's had really a lot of research. There's some intuitions, you can throw some ideas around, but no one's really kind of taken a formal approach. So there's even angles where like we need more academic research in that sense. Like academics have shown that a lot of the routing algorithms we have today are very non-private, but how to fix it, a little less so. So there'd be a lot of room to improve there too.
Definitely.
yeah, there's just so many different venues where we can actually make progress and try to start experimenting. And it makes me a little bit giddy because it sort of is this huge playground where we can explore new trade-offs and sort of try to improve. And that's one of the achievements that we got by basically lifting off of the chain, by no longer being on the consensus layer where every single change has to be approved by the entirety of the network, because it is a strong consensus algorithm we have to run on the base system. But by lifting off of the chain, we can actually get this freedom to experiment and basically get different parties try different trade-offs, and then sort of come back to the table and sort of discuss what worked best, what didn't work, and sort of come to a more cohesive picture of what we should do going forward.
Yeah, there's so many problems in Lightning. It's easy to get like nerd sniped, just kind of like go very, very deep in a particular problem. I think one of the cool things I've seen over the past maybe like 2 years or so, there's been like a lot of academic papers now, like actually doing Lightning stuff. Like I have like a Google Scholar alert, and like every day I see a new paper basically, and like I have like a little research channel I post in there. It's really cool just like seeing people kind of like recognize that this is like a thing to be working on, and all the kind of like interesting sub problems where it's okay, I can do pathfinding, I can do kind of like graph analysis, I can do like channel selection, I can do optimization. There's so many different problems we're working on, and it's like you're saying, it's so fun to be able to like pick and choose all this different technologies and like kind of solutions to take a look at.
So it seems like all the hype is currently Taro. Can you talk about shitcoins on Lightning briefly?
I don't know if I'd phrase it like that. I mean, people get free to what they want to do. But something that I was working on for a few months now, kind of like inspired by like, okay, what can we do with Taproot, right? So kind of like starts from the realization that, okay, well, Taproot has like a script tree, so you can commit different paths. Okay, maybe there's like a multi-sig, there's like a time lock, something like that. So okay, well, what if we committed other data in that tree, right? So okay, well, now that we have that other data, like how do we actually structure it? It's kind of the thing where it's like, this enables you to basically have like, you can hold assets within kind of like a single Taproot output, basically. So I have like my Bitcoin, but then I can potentially have like, 1,000 different assets. Maybe I have like a, holographic Beep Start card, baseball card, something else like that as well too. And the cool thing about it is like, it's like very kind of like, Bitcoin-like, right? It's like rather than kind of like try to create like entirely new VM and all these things or whatever else, kind of like reuse the existing Bitcoin script VM itself. So you effectively kind of like have this like virtual transaction graph which is embedded in the Taproot script tree basically with a similar kind of like asset witness and output format. Uses some things as far as like Merkle sum trees, different ways to do like efficient proofs. But the idea is like once people just upgrade basically, and the cool thing about it is like it doesn't actually require any base layer level changes, right? So once it's rolled out, people can actually just upgrade and start using it, on their own. And the cool thing also is that like because it's actually based on like the Taproot script tree, like if we have some like certain type of covenants, maybe like the Taproot update verify, that can actually constrain transitions basically, because if you can recompute the entire commitment basically, you can recompute the script tree, and you can basically say, okay, well, it must look like this, right? So I think it's really cool where it's like even if Bitcoin doesn't actually know about it explicitly, covenants can still eventually kind of like manipulate the thing that's going on there, right? And the Lightning part of it is that like given that it's actually based on Taproot and also has like a scripting layer in the actual system itself, this is what we're kind of like proposing doing is kind of like having the assets at the edges basically, right? So rather than like the network upgrade basically, you have a bunch of questions as far as like routing, liquidity, blah blah things like that as well too. It's like only if the sender and receiver updated you actually need to do this thing. This is really cool because now you actually retain all the network effects of Bitcoin in itself because now everything's actually crossing through Bitcoin the entire time, right? So maybe like a router is okay, well, I don't know what's happening, but I'm getting a lot more activity, I'm getting a lot more routing fees, I'm getting a lot more revenue. So I think it's a really cool kind of like feedback cycle as far as the network effect where like more demand at the edges basically means more capacity, which is more routing activity, which means more energy, which means more activity as well. So really excited about that.
So you can shitcoin, I can route your shitcoin, and we can still be friends.
Exactly. You can keep your hands clean if you want to, right? But it can be like other stuff. I can give you cool points. I can give you beef bucks. I can give you whatever. So I think that's the cool thing where it's fully opt-in basically. If you don't want to touch it, you don't have to touch it or whatever else. But indirectly, maybe it's going to like actually improve your routing node and actual routing revenue as well too. Because you can say, okay, now with this, maybe we can start to position it against like more directly like credit card or something like that, right? Because maybe people still want that fiat balance. Maybe they want kind of like other currencies, something like that. But now it's okay. Well, Bitcoin Lightning can be the massive crossing network for everything else. Kind of be the monetary backbone. You can do whatever you want to the edges, and the core of the protocol just stays Bitcoin fully, and that makes it a lot simpler as well too. We don't have to worry about other things, as far as like crossing different chains in the internal network, time locks, forks, things like that. That's all a nightmare.
So it's the strike pitch, but not centralized.
Yeah. So in theory, someone could take this and build a strike-like thing as well. And I think that's a beautiful part about like protocols. And it's going to be like an open protocol as well too. And we published some BIP drafts. Some of them are more complete than others. Definitely working on filling some additional details. But the idea is anyone can basically start to use this thing and build the strike in Nigeria or wherever else they really want to. So it's kind of really the cool thing about open protocols where people can just start to use it and improve it, and then it goes from there.
What's going on in LDK land? I remember you and Andre were lecturing me at Socratic last year about waking up mobile wallets when they're needed, async await. What's new, man?
Yeah. That's kind of loud. So yeah, our whole pitch is kind of to improve the ability of mobile wallets to integrate Lightning, where you have all these existing on-chain Bitcoin wallets. They're great. They have all their logic to download the chain and sync and store keys and do all that kind of stuff. But now you want them to add Lightning, and there's not really an option for them. They can start re-implementing Lightning from the ground up. We just talked about how we have 5 years of stuff to do, and all of us have teams of 3, 4, 5 people full-time maintaining a Lightning implementation, keeping it running, and adding all the features that we want to add. So obviously, that's a pretty big ask for most mobile wallets. Our pitch is kind of like, here, we're going to do all the hard work for you. You can integrate this. You can run it. And our pitch being on mobile means we have to fix a lot of the issues with mobile on Lightning today. And anyone who runs a big Lightning payment processor today knows that a lot of your payments fail because they're going out to a node that's on a mobile phone, and it goes out, and then the phone is not currently on the internet, it's sleeping, the app's not open in the foreground, or the phone's locked, and all of a sudden the payment bounces. Because turns out these phones are super, super battery life conservative. Anytime the phone's not on, it disconnects the wireless, it disconnects the LTE modem, and you can get no CPU access. So this is a major problem. You have payments that just fail. You can't actually receive a payment unless your phone is currently open and on the app. Depends on the device, but that is obviously a pretty unusable user experience. So that's, we were talking about exciting things about onion messages, and I think there's, as far as I know, the only proposal to do relatively decentralized or at least trustless offline payment receipt in Lightning was something I proposed kind of loosely a few months ago, but it depends on Taproot and onion messages and LSPs. So this is, it depends on these things that we have that are probably a year or two out because we have so much stuff to get done. And then we can start fixing these more fundamental problems that a lot of people are facing today that really hurt the user experience of Lightning, that really destroy it for a lot of users. And so yeah, we have a lot of work to do. But that's, so things are going well. We have Cash App shipped with LDK. We were sitting there talking about mobile, and then Cash App said well, we have all this complicated backend infrastructure. We want to integrate our Lightning node super tightly with that. And taking LND or Core Lightning off the shelf and running it is cool, but we want it actually really, we want the logging to go directly to our logging service, and we want the database to go to our database service, and we want blah, blah, blah. And so they built a node, from scratch using LDK, and that wasn't too hard for them. You just kind of plugged the things into the right place, and they've been pretty happy with it. It seems to work pretty well.
That's awesome. Christian, what's up with Core Lightning and plugins? Can you talk about this CL boss thing I always hear about? What is Greenlight?
Can we still call it C Lightning, by the way? Or
Yeah, I keep slipping up and calling it C Lightning, but no, Core Lightning it is. So
Hardcore.
Hardcore, yeah. So yeah, Core Lightning has always been sort of the bit of the Lego block kind of node where you can switch out individual parts, or at least that has always been the goal. And we started building out plugins, and some of the functionality that ships with Core Lightning itself is actually a plugin. So the pay command, for example, is implemented in a plugin, and you can swap out the logic relatively easily. And we've gotten some feedback from researchers that are looking into how to optimize payments. And they could just take the pay plugin and re-implement it with their routing logic and basically experiment with that quite easily without having to have all of the knowledge to actually assemble a full node. And we're going a bit further with that now with a new project called Greenlight, where we are actually taking the node and exploding it into a bunch of different parts and sort of reassembling it, running it on different infrastructure. The main node itself running on our infrastructure, but the keys are kept on the user side, and the front end is kept on the user side. And sort of this is a different trade-off from what LDK does, in that we don't try to bundle the node with the app itself, but we try to have every user have one node and sort of remoting in, which allows you to have a multitude of interfaces. And the way we approach the issue of being able to accept an offline payment is that you can have any number of front ends, but you can also have any number of signers present. And as long as any of them is present, you can still receive a payment, an incoming payment. And so I think that this is an interesting setup where we can sort of redistribute the competencies, and sort of we specialize in doing what we do best, and app developers don't even have to learn about how to run Lightning nodes themselves. It's one trade-off, but I see a multitude of different ways to sort of redistribute these parts in the future, making more interesting setups possible, where we can actually tap into a multitude of different use cases as well. And this has been ingrained in Core Lightning for the longest time. We've already always had the HSMD as a separate process, because we were eventually hoping to make it a hardware security module. And now we're doing that step of going in that direction of actually splitting parts out and redistributing responsibilities.
That's a great segue, actually. The next thing I wanted to ask you guys, no one ever shuts up about WASM. I'd like to go around and ask how you think WASM is useful in your implementation, and how you approach remote signing, as Christian was alluding to.
Cool. I guess we can go over this way. So WASM is definitely very cool. So we actually used it for this new project that we had called LNC Lightning Node Connect. Basically, the idea was, okay, like, we want people to have to kind of like have like a web application and kind of like securely connect that out to a Lightning node. So I think before people had like these like giant QR codes sending right macaroons, scale, or whatever else. So we kind of like devised this, protocol kind of like devised off of something called PAKE, which is like password authenticated key encryption. So you just basically put in this kind of, like pairing phrase basically, and you have like a secure tunnel from your node into the browser itself, which is really cool because now you can kind of have like a more native experience as far as building web applications like that as well. So what we ended up doing with WASM at that point, we actually compiled like most of LND into WASM basically, because we had a bunch of crypto as far as like ECDH things like that as well too, and all that's actually now in Go, right? So we actually have a bunch of like we have like a full gRPC client in Go. We have all the TLS stuff in Go. We have all the PAKE stuff as well too. So I think it's a really cool way to kind of like be able to distribute things. It's kind of like this intermediate, you can say like IR or binary layer basically, right? So it's kind of cool because you can basically have an English language compiled into this kind of like single slightly modified interpreter or VM and can like distribute that pretty easily. For Go, it's kind of like a little bit larger. You have to like because like you actually link the entire standard library. The WASM blob is a little bit larger, but we have a thing now where we're kind of like doing like a just-in-time load of it, where you can kind of have your own load as well too. Things really be flexible as far as like being able to like do more things on the web. I think the dream is kind of like basically have like a fully WASM node in the browser itself, have like a light client. So now at that point, it's okay, well, user kind of like have like a very like sleek onboarding experience. They download maybe a Chrome extension, boom, they get started. They don't need to worry about where their node is, move on for else. So and obviously maybe you don't want to put your life savings in that thing, a small amount, maybe do some tips or something else. But I think once you have that, you basically have the potential to do things like streaming payments on the web itself, stream for video, do the upvote thing, destroy paywalls, things like that as well. So I think it's going to be really powerful moving forward.
Yeah, so we're definitely looking forward to having some parts of C Lightning running in WASM. Core Lightning, sorry. Keep slipping up.
It's bound to happen.
But what scares me about WASM is basically that now it's possible to build to have a full node run in a browser tab. And do we really want to get into the habit of suggesting users to enter their seed phrase into a browser tab that might be just impersonating your actual wallet? But then again, like Rosebeef said, it is basically a requirement for us to have something like a browser extension or something like that. So yes, we will probably not run the full node inside of a browser window in the form of WASM, but we're definitely looking into having sort of the client libraries talking to Core Lightning and the signers run in a WASM context, be that a browser extension or a browser window. Such that you can still remote into your node, whether that's self-hosted or we manage it for you, and that's definitely something that we need to do if we want to reach all the users that we want to reach in the end.
Yeah, so Lalu said that the dream is to maybe eventually have a Lightning node run in WASM. So we have that. It works. You can take LDK. You can run it in WASM today. We've tested running some nodes in the browser. It's super lightweight. It doesn't weigh anything as long as you're not downloading the full graph data. So if you maybe have a smarter way of doing routing, and you're not routing a lot of payments, you're just like a personal node sending and receiving things. It's super lightweight. It costs nothing. The WASM binary is pretty small. So yeah, it works great. LDK doesn't take any stance on whether people should do things. We just provide the tools that they can do them. Certainly there are, obviously, having your keys for your Bitcoin in a website tab is pretty sketch. Having your keys for your Bitcoin in a Chrome extension or in a React client where it's actually a JavaScript web platform, but a separate application on your computer is maybe a very different world. So yeah, we do that. We support it. You can take the whole thing and run it in a web browser if you want.
Cool. How do y'all handle like Bitcoin access to PP network? Is it kind of like an RPC thing in that context? Or?
Yeah. So LDK does not. We have some pre-built things that you can sync the chain via like Bitcoin Core, but we otherwise just have a general interface for like, hey, provide us graph data. And there's actually two different interfaces. There's one that's more Electrum-like, and then there's one that's more kind of like Bitcoin Core or like full node-like. So you can kind of like however you want to sync the blockchain. We have an API that's like pretty similar to the way you're already syncing the blockchain, and you just kind of feed it chain data, and then we tell you what you need.
Can you serve it over DNS yet?
Full blockchain data over DNS, no, but you can download the headers over DNS. I do run a service to do that, so that's also fun. Or over wireless. So I don't know if NVK is here, but he's been doing like Bitcoin stuff over ham for a while, so you could do that too. That might not run in a web browser though.
Yeah.
Ham radio is going to be hard to run.
How do you get to the web browser tab to talk to your satellite dish?
Yeah, that might be hard too.
I need a dongle. One cool thing about like kind of like layering like high-level protocols, people know about the neutrino protocol. It's kind of like a way to do like clients on Bitcoin. And the cool thing about it, it's like actually kind of like stateless. Like the older protocols kind of like had you kind of like communicate with the node and kind of like match these filters and interactively. But this like basically download a filter, right? So now like one cool thing you can do with that is okay, well I can put that on like a CD on maybe HTTP2. I can download the headers, the filters on the blocks, basically just over this HTTP system itself. So that's really cool because now like the browser already do HTTP and like it's kind of harder to do kind of like more advanced like you don't really have like raw TLS or TCP sockets or something like that. So instead I can basically kind of like have that and download all the data over HTTP. It's going to be super cache everywhere CN-wise, so that can be like a cool way to kind of like kind of like navigate some of the trade-offs security-wise. Where okay, like we don't want people just to hidden some massive API like MetaMask or something like that. They can actually get the data. And the cool thing about POW is like it's objective. You can verify that you can verify the hashes, run the numbers, things like that. So it's a little bit better as far as security models compared to like everyone using one centralized API that can just lie to you because there's no really assurances with some of those other systems.
Yeah, I also provide the BIP157 header chain via DNS.
Oh, nice.
Want to download that over DNS, you could do that.
Yeah, I forgot about that.
Yeah, I mean, I find it really interesting how we sort of started out with this really small set of transport protocols, and by the way that the Bitcoin metadata is structured, we can actually just swap out the transport layer and offer different services on different kinds, be it DNS or HTTP. Or the Bitcoin protocol.
Yeah, and and the PDP protocol today in the Bitcoin, it just kind of like evolved that way, but there are other ways to do it. Like for example, Matt's done a bunch of work in the past as far as like improving block propagation, things like that as well too. So like protocol work is it's super fun. I mean, there's just so many things you can do. It's just kind of like all these puzzle pieces.
Gotcha. So I think we all are grateful to where Bolt 11 got us. But there's been major shortcomings. But some of the application developers have even taken it into their own hands with certain things like LNURL, lightning address. I know right now there's a priorities contention going on between Bolt 12 and AMP. Can you summarize AMP and maybe when or if we have a spec for it and the trade-offs?
There's a spec? I mean, yeah, there's a spec. It's just kind of a little bit dated. It's actually pretty up to date now, but AMP is basically, people probably heard of keysend, which kind of where you like spontaneous payment, you basically push payment over, right? That works by kind of including a pre-image in like the onion payload, which encrypts the nHop, and they basically decrypt, and then they use that pre-image to settle the actual payment itself. AMP is kind of like, you can say like the multipath analog of that. Multipath payments is basically a way to kind of like split payment up in different pieces. This basically uses kind of like something called secret sharing. So basically, I take the pre-image, I kind of like extort it into a bunch of different shares. I send you all those shares, then only after you have the final share can you extort it back to basically get the pre-image and settle everything else like that, right? So it kind of gives you, push payments in like a multipath fashion, right? And the one thing it has as well too, given that the actual sender is the one that's going to make the pre-image, you can have like a static invoice that's kind of like fully enclosed, right? So basically, you give me the invoice, I can just pay it over and over again. So it works by kind of like having other identifiers. So you have like a payment address or like a payment secret basically, something called a set ID. So this is like now your main identifier, and then every single new payment actually has a new set ID over there, right? So it basically gives you spontaneous push payments, but also kind of like a reusable invoice around itself. And obviously there's Bolt 12. Bolt 12 has a lot of other stuff with it as well. So AMP was kind of like okay, doing payments or whatever else. So I think Bolt 12 is kind of, to me, it's kind of like an invoice negotiation protocol, right? It has a bunch of other things as far as like negotiating invoices, all this like optional refund stuff. It has a new format, things like that as well too. While this one is something that can be deployed today because it's kind of like just mostly at the edges, and obviously like maybe like an address change in Bitcoin took a while to actually work properly. So maybe the Bolt 12 stuff like has a little more of a barrier, and there's other things that kind of like have similar functionality, LNUR, whatever else. I guess it depends on kind of like the trade-offs. If you want something that's more opinionated in the protocol, or if you want something that's a little bit more at the edges and people can maybe do what they do, because things like LN address and whatever else, people can update those on the fly and just release a new version versus kind of like requiring like larger changes as well too. But Bolt 12 has a lot of cool stuff into it. But I feel like maybe we can break it up and kind of like do it a little more incrementally, and then see exactly how the use cases turn out, and like talk to the people, the wallet operators and services as well to see exactly how things can evolve in the future.
Is it true that the main differentiation is AMP doesn't have like a proof of payment? That's what I often hear.
Yes. So I think To me, I think the whole proof payment thing, it depends on what you mean. Because I feel like I've been using Lightning for a while now. I've never had a thing where a service asks me for a preimage. Does the user even know what a preimage is? Is there even actually like a standardized format as far as like actually serializing what a proof payment is itself? So I think it really depends what you want there. But that is true where I know Boat 12 has a way where I think there's like a sender key, and you can use that key basically to like sign something to basically prove that you paid it. While with AMP, because it's spontaneous payment, there's not kind of like a way to like give you that capability. But once you add things like PTLCs, there's actually a way to do that, because then you can actually like have a key in the invoice and kind of like add that to the payment that you're sending out there as well too. So it's kind of a thing where it's like, this is better for maybe something like a donation, where I'm kind of like pushing you money, maybe the kind of like a streaming thing. But maybe if I'm doing something where I want recourse, maybe like I need like a shipping number or something like that, maybe you need that as well too. But I feel like at this point, I think discourse is kind of like missing that. I haven't really seen anything like that, because I feel like say people
There are some other
people probably ask you for an invoice number, right? And then you can go from
if
there.
you want to do an external signer, a verifying external signer, you need proof of payment. So actually, AMP and KeySend are basically break stuff like Greenlight in like a secure model. Or if you just want to have a hardware wallet that's doing the actual signing, you need to not have that preimage in the onion. Otherwise, you have to like do more hops to have the onion decrypted on the thing. It's a lot more painful there.
Yeah, I feel like for me, proof payment is one of the things where I think us as developers think it's cool because we actually have a thing, but then I feel like practically I haven't really seen people really demand it that much, just because there's that extra step of, okay, how do you serialize it, how do I interpret it, versus just telling them, what's my invoice number, which is probably what you're doing anyway. But I think it's definitely cool. For me, I feel like we need to like, mature the concept basically, and just like say, okay, what do we need? People know Connor Fremnick, who used to work on Lightning stuff, he had this like massive matrix basically, basically the different types of proof payment, right? For example, like if I have the preimage, that proves that like someone paid maybe gave me the preimage. That doesn't really prove that I uniquely paid. You kind of like maybe need some digital signature scheme along that as well. So it's okay, well, I have the preimage and I have the signature that proves so I can pay as well too. So I think there's kind of like a gradient as far as okay, well, proof payment as check the invoice is paid versus proof payment. Okay, there's like a cryptographic proof basically that no one else can actually forge or produce. So definitely some nuance there. I think
there's also just very different. Like, what are you trying to accomplish, right? There's like, are you trying to do donations? In which case, like KeySend, AMP, Bolt 12 are all options. Are you trying to do payments to a store? Well, KeySend and AMP aren't really. Like Bolt 12 or like LNURL or Bolt 11, but no one wants Bolt 11. Are options. Are you trying to do a payment to like a non-custodial mobile? Okay, now you need like Bolt 12 and then maybe some extensions on top of that. And like LNURL and KeySend and AMP don't do anything for you there. There's a lot of different. There's a lot of different potential things you want to pay and different ways you want to pay, and from different clients to different clients. And Bolt 12 forms a good base to build basically all of those. But then there's also more immediate term for different specific use cases. There are good solutions like LNURL is great if you're paying someone who runs like an HTTPS server, like a web store. KeySend is great for donations. AMP is cool, but I'm going to say something a little controversial. MPP doesn't actually really matter. Multipath does not make a big difference for payment success, for payment.
I don't know about that.
Your bigger concern is network flow.
But I mean, but you can say like there's certain payments that you can make with MPP that you couldn't.
That is true.
Right?
That is true. Those are I mean, are you donating $10,000?
Or just someone has
I might be
fragmented
interested in
channels.
doing a payment for $10,000.
Yes, you might be, but specifically in the donation context.
In the donation context, I do have a point. I do have reason to want a proof of payment. By the way, I want to be able to prove to my tax office that I donated.
That's a whole different another complication. But for the most common values of Lightning payments today, MPP doesn't really make.
I think for smaller amounts, and I think it's always an interesting thing where we had MPP, then we had Wumbo. Now you have like really big channels there. You have like 1 or 2 BTC channels as well. So
exactly.
I'm sending 1 Satoshi through like a 200 million Satoshi channel. It's probably going to work as well too. But I think the interesting part of MPP is people are starting to do kind of like more complex kind of flow analysis as far as trying to have like the optimal route of particular things like that as well too. So I think that's really cool in that domain. But sometimes maybe you can probably just try it, but it's a very small amount. But I think once you get like much larger amounts, basically, people are doing like 1 BTC plus. Maybe they're doing things like loop and like moving larger funds around. Then I think maybe that's more. There's kind of like a theoretical thing where you can say, okay, if you can split the payments and enough liquidity exists, in theory you can get there eventually. But eventually maybe isn't good UX wise.
So the bigger problem is the flow is the question.
The whole idea of doing min cost flow from Rene is basically based on as you approach the minimum cut in the network. When it comes to liquidity, you have to get more optimal. If you have a min cut that is basically like 3 Bitcoin and you want to send 10,000 Satoshi, why do the work?
Right.
Yeah.
But if I approach that min cut, you basically are forced to become really clever.
The problem is if you approach that min cut, suddenly it doesn't, like your individual payment doesn't matter, it's the total flow through the network, right? You have so much flow through the network that the relative gain of doing something more complicated for an individual payment is substantially less. Like your payment has to be a small fraction of the total flow, and thus you don't really, and because it's a small fraction of your total flow, you don't have to be quite as optimal on the individual payment.
Yeah, that's true. But interestingly enough, your own capacity and the capacity on the recipient's end is usually the actual min cut.
Right.
So if you had a negotiation mechanism, onion messages, where you could sort of gossip this information back and forth, you could potentially figure out quite quickly if a payment is possible at all, because it's either you or the recipient who is going to limit your capacity. So,
or
so
I can
suddenly
have
you're
service and
MVPing
just
just based on your channels.
Yeah, but I think as Matt said as well, payments have a lot of different parameters. So maybe depending on the payment size, depending on latency as well. I think there's going to be in the future probably different algorithms people will choose based on maybe the payment size or kind of their own parameters. And it's kind of a wide open thing where it's you can do whatever you want basically. And I think the cool thing is incentive-wise, as new algorithms are developed, maybe the routers themselves which is more or less depending on the which the client's getting smarter. So is the edge going to get smarter, or kind of are the internal routers going to get smarter as far as manage the liquidity better, do the balancing as well. Definitely still really wide open I think, and really cool to see more research in this area, because this is kind of thing I can say probably has the most leverage, increasing payment UX basically, and speed and latency. That just makes it work, and that's what makes it seem magical.
So as Matt was pointing out before, there is a wide spectrum of different preferences users might have when it comes to payments, right? If I'm standing in front of a point of sale, I really do care about latency. I don't want to be there waiting for a minute or so until my payment goes through. If I'm interested in just doing some exploratory probing, I don't care about latency. If I care about getting the cheapest possible payment, I might spend some more time actually computing the optimal route there. Or if I'm just interested in making sure this payment goes through no matter what, then I might use a different algorithms. And there's not just the algorithm side, but also how do we expose that to users in an understandable fashion. So for example, we always took the stance that users shouldn't care about fees too much. We for each payment we give the routing algorithm, we give it a budget, and it's free to do whatever it wants to do inside of that 0.5% budget we give that algorithm. And part of that we actually use for obfuscating our routes by increasing CLTVs, by allowing ourselves not to take just the cheapest route, because cheap routes are easy to predict. If you see a partial payment and oh, that's probably from this guy because I am his cheapest path. So you're leaking some information there.
Yeah, I think that's an interesting point as far as cheap payments and privacy. For example, they're kind of these zero fee nodes, not base fee, completely zero fee. And I think the interesting thing is they're kind of a black hole because they cycle payment attempts, right? But if I was wanting to kind of monitor payments, wouldn't I just have a completely zero fee node as well too? So maybe you should want to avoid them, because it's okay, skin of the game. I want to pay you to have some signal that you're not just collecting my stuff.
Shall we go negative fees maybe?
Yeah, are you selling my data because it's zero fee or something? I don't know.
I mean, yeah, I expect chain analysis to properly cost what my payment anonymity is worth to them, and if they pay me enough, I will de-anonymize myself to them. I need them to pay me. So
I would just stream my logs to them.
Well, how does that affect the channel DB? Because if there's zero fee, you're doing more payments, right? If you're logging all that info.
I mean, you're getting forwarded more probably.
Yeah, exactly.
Or get more forwards.
There's nothing enlightening that you need a sufficiently sized disk, but it's a small amount of information per channel state update, and there's nothing, and the total size of the things you need to be actively dealing with as you update the state is constant size. So there's no real scaling issues there in terms of history and lightning.
Funnily enough, there
are some application issues that need fixing, but sorry.
Funnily enough, the more limiting factor here is having to touch the disk at all.
Right.
Having to basically just flush out to disk and make sure that all of this data is actually written to disk. Even on a relatively quick SSD nowadays, that takes time as compared to just operating in RAM. And that is one of the reasons why Onion Messages was created, because the Onion Messages do not have to have the node touch the disk at all. You can basically forget all of the information that an Onion message told you. Maybe a reply might fail if you're restarting in between, but basically just removing that extra load that is currently used if you do communication via keysend or similar protocols is a huge win already for us.
Yeah. And I think one open question with the Onion stuff is like, some people are saying, okay, well, should it be free? Should it be priced? How do we like rate limited as well too? Because like at least like attaching HLCs, there's kind of like some cost. Obviously it's not the most efficient thing in the world, but it's kind of the thing where it's like, okay, like do I want to be forwarding all of these like images or videos for free basically? Can I like charge for that? If you can charge for me, that's interesting because now all of a sudden I can basically like make money off of routing revenue, but also make money off like forwarding bandwidth as well too.
Let's not add bandwidth as a cost to Lightning.
Yeah.
But the cost is already there. Every single payment is 1.3 kilobytes already, right? So
the main
trivial.
The main problem with basically saying that keysend has a cost, it has a cost, but the cost is borne 20x by the network itself.
The cost is mostly the wear out of my disk.
Yeah. So it's not like imposing a minimal cost to the sender of a keysend message makes it so much better than an Onion message. Because the cost that this keysend is having on the network itself is much greater.
Yeah.
And part of that is having to touch the disk. Part of that is disk wear. Part of that is having to keep state across over time until the channel is closed.
Yeah, at the same time, you can raise like your min HCLC if you say, okay, well, I want to do one more payments alone and things like that. But I think it's just worth at least kind of like weighing some of the trade-offs and like the inherent costs, where it's okay, like free forwarding of messages, like maybe we should try like see incentive-wise, can we rate limit them maybe with like kind of like some congestion control algorithm, or can we actually charge for that from the get-go? But if you can charge for it, maybe that's just like supplemental income as well too. Maybe you kind of like get this whole new internet thing from like Silicon Valley along the way.
Oh, we need that compression algorithm.
Yeah, exactly. Mid allowed, dude.
That'd be nice.
Well,
Middle
I think
out.
that's all, folks. We're done.
We ran out
That's
of
where the
time.
timer is. I didn't see that.
Yeah.
It is still counting up.
Yeah. I guess before we head off, seems like the whole Lightning Network is mainly just Umbral people. Do you have one thing you want to tell them, if anything?
What do you mean? You like the plebs
Umbral
or?
node runners, yeah.
I mean, hey, we love y'all basically, right? Like, I think it's really cool to kind of like have like grassroots community of people helping each other out, kind of like spreading different knowledge. And I think it's kind of like a cool hobby. It's like, oh, I'm like doing my part basically for the network compared to kind of like just like maybe something that isn't really contributing at all, or that's just kind of like more like speculative or something as well too. So it's cool.
We need a world where we have a lot of those to balance out the fact that we're getting increasingly more of these large, custodial sort of like Cash App or whatever running very large nodes. Like we need lots of plebnet to balance that out.
Yeah.
So keep doing it.
Definitely, feedback from plebnet has been awesome, and we need more of that. This is what gets us going. This is what basically helps us develop Lightning further, and this is the feedback that will get us to a place where all of this is actually stable and not siloed into some weird big company. So keep on doing it.
Yeah, the users.
Cool.
We're here for the users at the end of the day. So.
Yeah. Well, awesome. Thanks, guys.
Cool.